Alright, when we are asked to write a linear equation, we know that it has to come in the form y equals mx plus b, where x is our independent variable, y is our dependent variable. But more importantly, m is our growth rate or slope, and b is the starting value. So we'll start off, if we're given a graph, what we can do. Well, first thing that we should look for, should be pretty easy, is our b value. All right. And our b value is just the y-intercept. And our y-intercept is 0, 3, so our b value is 3. So then we just need to look for the slope. Well, if you're given a graph, a slope triangle can help. You want to pick out some lattice points. I think I'll pick this one, and I'll keep our intercept as the other lattice point. So I'm going to do a growth triangle or a slope triangle. So this would be down 2 to the right, which would be positive 5. So you got to remember, slope is change in y over change in x. Rise over run, so people like to say. So that would be down 2 over 5. And so we got negative divided by a positive, so that'll remain negative. So our equation, we're done, we just got to put it together. Negative 2/5 x plus 3. So that is our rule for this particular line. So we're going to move on. And now we're given kind of the same thing, except we're just given 2 points. We're not given a graph, but our goal is the same, to find m and b. Well, when you're given 2 points, we can find the change in y and change in x, and therefore we can find our slope right away. You'll see this a lot. Well, our change in y, all we have to do is subtract them. And it's kind of important to do it in the same order. So I'm going to do negative 15 minus 3. Well, for our change in y, then I want to do that in the same order. I want to do negative 5 minus 1. Alright. And that will be equal to, well, we got negative 18 on top, negative 6 on the bottom. Reducing that gives us a nice 3. Doesn't always come out nice and even like that, but this problem does. So we can go over to our problem now, and we have the m value, our slope, our growth rate. So we're growing 3 each time. Well, from here, we just want to find out what we need to add or subtract to the end. So go ahead and pick one of the 2 points to put in the equation. I'm just going to use the 1, 3. It seems simple enough. So y has to be 3 when, let's go up here, y has to be 3 when x is 1. Well, if you take a look in this particular case, our b value actually just has to be 0. Alright, so you can do this if you wish, but either way you look at it, we don't have to actually add anything on. So y equals 3x plus 0, but you don't need to write the plus 0 part. So this equation actually goes through the origin. So that one was interesting, the b value being 0. Alright. Here, same type of problem. This one's actually a little bit easier, a little bit quicker. They already give us the slope. So that's nice. So I'm going to show you one here. I believe this one does not go through the origin, but we still use y equals mx plus b. Should be a little quicker since we already have the slope. Y equals 2x plus b. We need this to work out for this particular point. So we're going to head, and when y is 17, x has to be 10, and then we just got to figure out what we need to add or subtract to make this work. And you can see from here, b has to be negative 3. If you don't see that, go ahead and solve for b right away. And there it is, b has to be negative 3. So we're done. We just got to write the final solution here. Y equals, our slope is already 2x, and we have to subtract 3 to make this work out. So our starting value is -3, and we're done with that one. So that's very common. You see that we did that 2 times, plugging in a point to help find the b value. Here, we're not going to finish these off because they're very similar to the 2 problems we just did. But remember, we want to get y equals mx plus b filled in. Now they give us a line. They give us y equals 4x minus 1. They're saying that line is parallel to the one that we want. Well, if you remember, parallel lines have the same slope. So really it turns into a problem. Our slope of our line will also be 4. The only difference is ours needs to go through -2, -6. And just like we did before, then we can find our b value. So we're done with the line they give us because ours will not go through -1, all right, for our b value. So we need to find b. We're not going to finish it off, but what you would do is you'd put -6 in for y. Our m is 4. X would have to be -2. And if you want, you could solve for b on your own. But that's what you'd have to do there. And then one more very similar problem. The only difference is they're giving us a line perpendicular to the one we want. What you have to remember about perpendicular lines, we want a line perpendicular to y equals 1/3 x minus 1. Well, therefore, our slope, if you remember, has to have the opposite reciprocal. So if you start with 1/3, you take the opposite and the reciprocal. Reciprocal means flip it, and then we want the opposite. All right, I'm not going to put equal because they're not equal, but 1/3, if we want it perpendicular, needs to turn into -3/1 or just -3. So what we would do, use a slope of -3, use the 0.6, -2, and once again, using y equals mx plus b, when y is -2, x is 6, and then we'd have to find out what to add or subtract from there, and you could finish it off. But very similar problems. Those should help you write equations for lines. The main thing is to get your m and your b. Find the slope somehow, then use the slope and the information to help find b, and then you're done.